Okay, in this video, I'm going to talk about geometric sequences and finding the general term of geometric sequence. And then I will do a couple of examples so that you can have a better understanding of how to find the general term for geometric sequences. So first, starting with the definition, a sequence is geometric if each term can be obtained from the previous term by multiplying by the same non-zero constant, or if the ratio of two consecutive terms in a sequence is constant. So I'm going to give you an example. So if you have 2, 4, 8, 16, 32, and so on. So this is an example of a geometric sequence, and here you can see that 2 multiplied by 2 gives you 4, 4 multiplied by 2 gives you 8, 8 multiplied by 2 is 16. So according to the first one, if a sequence is geometric, if each term can be obtained from the previous by multiplying by the same non-zero constant. So in this case, that same non-zero constant is 2. So you can find out whether a sequence is a geometric sequence by looking at if you multiply the previous term by the same number and it gives you the next term, and then keep on doing that, then it's a geometric sequence. The another way of doing is you can also do 4 divided by 2, 8 divided by 4, and 16 divided by 8, 32 divided by 16. So again you get 2 as a ratio, and this ratio has a special name, and this is called common ratio. So if you have a common ratio for each term in a sequence, then that sequence is called geometric sequence. Now we are going to see how can we write down the formula for this geometric sequence. I'm going to again do with an example here. So as you can see here, when you had 2, so we can write this as 2 times 1, this 4, because we know that the common ratio in this case is 2. So we need to use this to explain the pattern here. So 4 can be written as 2 times 2. Now 8 can be written as 2 times 2 times 2. 16 can be written as 2 times 2 times 2 times 2. So this 2 is your, so this 2, we can keep this 2 as a constant, and then you can express this one as 2 into 2 to the power of 0. This one 2 times 2 to the power of 1. This is 2 to the power of 2. This is 2 times 2 to the power of 3. And this is u1, this is u2, first term, second term, third term, and fourth term. So if we want to find un, that's going to be, because here there is no change in this 2, so 2 will stay here, and then you will have 2 to the power of, so if it's first term, the exponent of this second 2 is 0, 1 less. If it's second term, it's 1. If it's third term, it's 2, which is again 1 less. So if it's 4, it's 3, which is 1 less, which means here, if you have n, it should be n minus 1. So this will be the general term for this sequence. And now we can even further combine it. So this is same as 2 to the power of n here in this case. So which again, you didn't have to use all of this thing, because it's quite easy to find a rule here, because 2 is 2 to the power of 1, 4 is 2 to the power of 2, 8 is 2 to the power of 3. So whenever you have any sequence, if you can find the general rule without using any formula, that should be your first step. But if you cannot, then you need to look at whether the sequence, what kind of sequence you have. And if you have a geometric sequence, then you need to find the general rule. You need to find the general rule, and for that I'm going to generalize, not with an example. So let's say that if we have u1, comma u2, comma u3, and then you have un, and I'm trying to find what is the nth term here. So now if you remember, r is same as u2 over u1, because r is the common ratio, and pay attention to, because it's always the second term divided by the first term, and then, or it can be written as u3 over u2. So similarly, if I keep on going, so r is going to be un divided by un minus 1, or if I go further, this is same as un plus 1 over un. So it's always the second term divided by first, third term divided by second, nth term divided by n minus 1th term, and then n plus 1 divided by nth term. So this is the common ratio. Now what I'm going to do is, if you look at here, u2 is u2 divided by u1 is r, which means u2 can be expressed as u1 times r. So which means I can replace the u1 will stay as u1, u2 can be written as u1r. Similarly, u3 is, because this u2 is when you multiply u1 with 1r. Similarly for u3, what do you need to do? Because here you multiply by r, but then again you will multiply another r here. So which means u3 is going to be u1 r to the power of 2. So if you keep on doing this thing, so I'm going to just write down here. So we got u1, and then we got u1r, then we got u1r square. So if I keep on continue with this pattern, so what will be my un here? So un, because for first term I have u1 r to the power 0, similar to the example which we did here. This will be r raised to power 1, but this is u2 if you remember. This is u3, which means r to the power of 2. So for un, this is going to be u1 r to the power n minus 1. So this is your general term. So un is equal to u1 r to the power of n minus 1. I'm going to write down clearly here. So your general term is u1 r to the power of n minus 1, and remember r cannot be equal to -1, 0 or 1. So this is not possible. Your r, if r is 0, then we don't have a geometric sequence. If r is 1, again the same thing, and if r is -1, it's again the same thing. So r cannot have the values of -1, 0 and 1, and also your u1 cannot be 0. So u1 has to be some number. It can be positive, negative. The terms can be positive, negative, fraction, and the another important thing is n has to be a whole number, because it's number of terms. So you cannot have 1.5 term, or you cannot have 3.5 term, or 3/4 term. So n has to be whole number here. So this is how we find the general rule for the geometric sequence. It's very similar to arithmetic sequence. In arithmetic sequence, you use plus and minus, addition and subtraction as your mathematical operations. In geometric sequence, we always use division and multiplication as your mathematical operation. So this is something which you need to remember. So in geometric sequence, multiply and divide. So I'm going to do a couple of examples so that you can have better understanding. So example number 1 is the sequence is given, and you have to show that this sequence is geometric, and then you have to find the general term and then find the specific term, and in this case the 10th term. So I'm going to start with show that. So the first bit they are asking you to do is show that. So to show that, we need to show that there is a common ratio. So that's what we need to show, that there is a common ratio here. So to find the common ratio, we need to do u2 divided by u1. But if you have 4 terms written, you have to make sure that you are finding the common ratio for all of them. So you just cannot do the ratio only for first 2 terms, because there might be some tricks. So you have to make sure that you are getting a common ratio. So I'm going to do that for another one, 6.75 divided by 4.5, and then 10.125 divided by 6.75. So this one, I'm going to use calculator to do that. This is 1.5, and now I'm going to check it if I'm getting the same answer here. So 6.75 and then divide by 4.5. So this is also 1.5, and the next one is 10.125 divide by 6.75. I always, whenever I do the division, I prefer to do using the fraction, so alpha y, and then the first one, and we have to do 10.125 and then divide by 6.75, and it should give me 1.5. So that is also 1.5, which means we have a common ratio 1.5. So our common ratio is 1.5 here, and that's how we show that the sequence is geometric. Now part B, they want you to do is find the general term, and now we already know un is equal to u1 r raised to power n minus 1 is your general term, and here u1 is 3, r is 1.5, and then your un is going to be 3, 1.5 to the power of n minus 1. So that is your general term. And now part C, they want you to find the 10th term, which means I will substitute n by 10. So that's your 3, 1.5 to the power of 9. And this is your answer. And now you need to use a calculator. You can enter this in calculator. So you can do 3 times 1.5 raised to power 9. So you can find like that. Or what else you can do here is you can substitute this as y1. So you can do y1, and your y1 is, so I can substitute y1 as the rule which we got, 1.5 to the power of, we got x n minus 1. I'm going to use x minus 1 here. And then I can go to second table set, and I can start my table at 10 since they are asking you to find u10. And then I will go to second graph, and then it will give me the value of 10th. So it's up to you whether you want to find the 10th value using y1, entering your rule as y1, and then from there, or you just can use the screen to enter your 3 into 1.5 to the power of n. So your answer in this case is 115.33. So that's your u10. Okay, so the next example is a geometric sequence has u3 is 18 and u10 is negative 39,366. Find the general term. So again, we know un is equal to u1 rn minus 1. Either you can use that to write down what is u3 in terms of u1 and r, and u10 in terms of u1 and r. But I will strongly advise you to memorize that. Whenever you have u3, it's u1 r to the power of 2. So the power of r is always 1 less than. So u10 is equal to u1 r to the power of 9. So I'm going to set up these two equations here. So since here in u10 I have r to the power of 9, which is more than the second one, so I'm going to write down this first. So this is equal to minus 39,366, and u1 r square is equal to 18. So now we need to find u1 and r. So in arithmetic sequence, we always use, as I said, addition, subtraction. So we always end up getting a simultaneous equations, and then we know how to solve the simultaneous equations. Here we also got two equations, but it's not with addition and subtraction, it's with multiplication. So what we need to do is we have to find u1 and r to find the general term, and there are two conditions given. So what do we need to do to find u and r in this case is we divide these two. When we divide these two, so that's why I wanted r raised to power n as my first equation, because I don't want to get, when I cancel out the things, I don't want r to the power whatever is left in the denominator. So now I can cancel out, u1 and u1 will get cancelled out, and then r raised to power 7 is equal to minus 39,366 over 18. So for this one you have to use a calculator. So I will advise you not to do this calculation first and then find the seventh root. What you should do is you write down negative 39,366 over 18 and then seventh rule. And now you should be able to use the calculator to do that. So I'm going to show you how to use the calculator for that. So because we have to find the seventh root, so you press on 7, then you go to math, and then you choose number 5, and after that you go to alpha and y and enter the fraction. So the numerator I have is negative. So when you enter negative numbers, you have to press on this key, so negative, and then you have 39,366 and then divide by 18. And now I'm going to press on. So I will press on enter, so it should give me the answer. So my r is equal to negative 3 here. So once I have r, I can substitute this r in any of these two equations. But again, do not complicate your calculations. So for that purpose, I'm going to enter r is equal to negative 3 in second equation. So u1 negative 3 square is equal to 18. So u1 into 9 is equal to 18. So u1 is equal to 2. So I got u1, I got r, negative 3. So I'm ready to write a general rule. So I have to substitute this and this into my given equation here. So now un in this case is going to be, because un is u1 r raised to power n minus 1. So u1 is 2, r negative 3, use the bracket here, n minus 1. So this is my un here. So that's my final answer here. Okay, now the next example, next and last one. Which term of the sequence is the first to exceed 5,000? So again, first, because right now I'm doing a lesson on geometric sequence. So, you might assume that, and that will be my assumption also, that it's in geometric sequence. But if you have these kind of questions in exam, and in exam you can have mixed questions, so you have to make sure that whatever sequence is given, you need to first check that what kind of sequence you have. Is it an arithmetic sequence, or is it geometric sequence, or any other kind of sequence? So here I'm going to look at, I can see that 4 square root of 3 divided by 4 gives me square root of 3. And then 12 divided by 4 square root of 3. Now I need to see whether it gives me square root of 3 or not. So I have to get rid of this radical in the denominator. For that I have to rationalize it. So when you rationalize, you don't have to rationalize using 4 square root of 3, 4 square root of 3, because this is the radical part. So I'm just using that radical part to rationalize it. So I got here 12 square root of 3, 4 times 3, which is 12. So I again got square root of 3. And remember, we have to verify this for each and every, we have to use each and every term to show that we are getting a common ratio. So it seems like we got common ratio of square root of 3 using first two terms. We got a common ratio square root of 3 using second and third term. And now I'm going to verify using third and fourth term as well, and you can see this is also square root of 3. So we can say that this is GP, geometric progression or geometric sequence, same thing. So R is equal to square root of 3. So we got the common ratio, which in this case is square root of 3. Now we need to find which term of the sequence is the first to exceed 5,000. So I know that un is equal to u1 rn minus 1. So I'm saying that I don't know which term it is. So I'm saying that it's the nth term or the general term. If you remember, the nth term is same as the general term, last term, or nth term. So I'm saying that I don't know which term it is. So let's say it is un. So I'm going to write down, and I want un first n when this whole value will get exceed 5,000. So my un in this case is u1, which in this case is 4. So 4 square root of 3 n minus 1 greater than 5,000. And I need to find my first n, because there will be lots of n where you will start getting the values greater than 5,000. So I'm again going to use calculator to do that. So you will enter your function. The first one, the left hand side, is 4 times square root of 3 n minus 1. So I'm going to enter that 4 times square root of 3 to the power, instead of n I'm using x minus 1, and then I want this to be more than 5,000. Now I'm going to go and set the table. You don't have to start the table with 1, because you clearly can have some kind of an estimation here. So I'm going to just start my table set at 10. Okay, it's already 10 here. So if it's not, you can set it to 10. And then you go to second graph, and then from here you can see what is the first value when you got the term value greater than 5,000. So I can see that this is when n is 14. So your n is 14 in this case. So this kind of questions will be a calculator question. But sometime it could be a simple one where you don't have to use the calculator, and you should be able to do it without using calculator also. So that's it for today's lesson.